Hello everyone, I am JP Roxas.
Hey, my name is Geremy Antonio.
And I am Marcos Encabo, and we are from grade 11, STEM, St. Mark.
I am Lamiya Abdulkadil.
And I am Leonard Cardenas, and we are from grade 11, St. John ABM.
And today we are going to discuss how to identify the frequency distribution table, mean, median, model class, standard deviation, evaluating a histogram, and summary of the findings using the data that we have gathered from grade 7 in their first and second term performance assessment in mathematics. So we are going to start off with Mathematics 7 first term performance assessment.
Construct a frequency distribution table. You must first identify the class range. Tally F or frequency, X sub M or midpoint, CF or cumulative frequency, F times X sub M, X sub M minus mean, X sub M mean squared, and F times X sub M minus the mean squared. For the first column, we will try to identify the class range, since the total score is 40, which is divisible by 5. We will use the 5 as the class size in this data, so we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30, 31 to 35, and 36 to 40.
For the second and third column, we will identify the tally and frequency. And according to the given data, there is one student who got a score from 1 to 5. No student got a score from 6 to 10. 4 students got a score from 11 to 15. 14 students got a score from 16 to 20. 11 students got a score from 21 to 25. 7 students got a score from 26 to 30. 9 students got a score from 31 to 35. And lastly, 4 students got a score from 36 to 40. And to sum it up, there are a total of 50 students.
For the fourth column, we will identify the X sub M or midpoint. To identify the X sub M, we will need to find what number is in the middle part of each class range. The midpoint or middle point of 1 to 5 is 3 because the number is in the middle. In 6 to 10 is 8, 11 to 15 is 13, 16 to 20 is 18, 21 to 25 is 23, 26 to 30 is 28, 31 to 35 is 33, and lastly, 36 to 40 is 38.
For the fifth column, we are going to identify the CF of cumulative frequency. To identify the CF, the cumulative frequency is calculated by adding each frequency from a frequency distribution table to the sum of its predecessors. The last value will always be equal to the total for all observations. Since all frequency will already have been added to the previous total, so first we have 1, then 1 again, since the next frequency is 0, then plus 4, so 5, then plus 14, 19, then plus 11, 30, then plus 7, 37, then plus 9, 46, then plus 4, 50, which is the same as R. So with this, we can affirm that our calculation is correct.
For the sixth column, we're going to identify the F times X sub M, which is already described, the frequency multiplied by the midpoint. So we have 1 times 3 is equals to 3, 0 times 8 is equals to 0, 4 times 13 is equals to 52, 14 times 18 is equals to 252, 11 times 23 is equals to 253, 7 times 28 is equals to 196, 9 times 33 is equals to 297, 4 times 38 is equals to 152, and to sum it all up, the total is 1205. So for the seventh column, To identify the x sum minus mean, we must first find the mean.
To find the mean, we're going to use the formula mean is equal to the summation of f times x sub m divided by n. And according to the frequency distribution table, the summation of f times x sub m is 1205 and the n is 50. Then substitute the values to the formula. So now we have 1205 divided by 50. Then divide, so we will get 24.1 and that is our mean.
And back to our frequency distribution table. To identify the seventh column, we will need to subtract each x sub m to our mean, which is 24.1. So we have for the class range of 1 to 5 is the midpoint of said class range, which is 3, minus the mean, which is 24.1 as said previously, which is equals to 21.1. Then for class range 6 to 10, we have 8 minus 24.1, which is equal to negative 16.1. For class range 11 to 15, we have 13 minus 24.1, which is equal to negative 11.1. For 16 to 20, we have 14 minus 24.1, which is equal to negative 6.1. For 21 to 25, we have 23 minus 24.1, which is equal to negative 1.1. The class range 26 to 30, we have 28 minus 24.1, which is equal to 3.9. For 31 to 35, we have 33 minus 24.1, which is equal to 8.9. And lastly, for the class range 36 to 40, we have 38 minus 24.1, which is equal to 13.9. For the eighth column, we will need to square each of the answers from column 7, or the x sub m minus the mean, to find the answer for x sub m minus mean squared. So first, x sub m minus mean, we have negative 21.1 squared, which is equal to 45.21. For the second one, it's negative 16.1 squared, which is equal to 259.21. For the third one, we have negative 11.1 squared, which is equal to 123.21. For the fourth one, we have negative 6.1 squared, which is equal to 37.21. For the fifth, we have negative 1.1 squared, which is equals to 1.21. For the sixth, we have 3.9 squared, which is equal to 15.21. For the seventh, we have 8.9 squared, which is equal to 79.21. And finally, for the last class, we have 13.9, which is equal to 193.21, totaling 1153.68. And on to our next slide. For the ninth column, we will need to multiply the frequency by the x sub m minus mean squared. So for the first one, we will need to multiply 1 by 445.21, which is equal to 445.21. For the second one, we have 259.28 times 0, which is equal to 0. For the third one, we have 123.21 times 4, which is equal to 492.84. For the fourth one, we have 37.21 times 14, which is equal to 520.94. Sorry. For the fifth one, we have 1.21 times 11, which is equal to 13.31. For the sixth one, we have 15.21 times 7, which is equal to 106.4. For the seventh one, we have 79.21 times 9, which is equal to 712.89. And for the last one, we have 193.21 times 4, which is equal to 772.84, totaling 3,600, 3,064.5. Sorry.
Now that we have identified what needs to be located in the frequency distribution table, we will now find the median. To find the median, first we must find the median class. So to find the median class, we're going to use the formula n divided by 2. Since we already know what n is, which is 50, we're going to divide it by 2, which will be 25. And now we will need to find the row that has a cumulative frequency higher than 25, and that is 30, which is in the class row of 21 to 25, and thus 21 to 25 will be our median class. Next step, we will find the median. To find the median, we will use the formula m sub n is equal to L plus open parenthesis n over 2 minus CF all over F close parenthesis times H, where L is the lower limit of median class and N is the number of observation or total number of frequencies, and CF is the cumulative frequency of class preceding the median class, and F is the frequency of median class, and lastly, H is the class size. So based on the frequency distribution table and median class, the L or lower limit of median class is 21, the N is 50, the cumulative frequency is 19, the frequency is 11, and the class size is 5. So to summarize our data, we have L is 21, N is 50, CF is 19, F is 11, and lastly, H is 5. And we are going to apply this to our formula, and we will get 23.72727272 or 23.73 if rounded off to 2 decimal places, and this will be our median.
Now we will identify the modal class, which is 16 to 20, since it has the greatest number of frequencies, which is 14.
Now, we must calculate the standard deviation, and we're going to use the formula square root of f times summation of x sub mean squared all over n. And according to the frequency distribution table, the summation of f times x sub m minus mean squared is 3064.5, and the n is 50. Now we're going to apply these to our formula, in which we will get 7.82879,301 or 7.8288 if rounded off to decimal places. And this will be our standard deviation.
Now, we can create our histogram, and we can use a bar graph since it is easier to identify what type of distribution it is, which in our case is a positively skewed since the curve is skewed in a positive direction.
And to summarize our findings, according to the data acquired, 50 students in grade 7 took their first term performance assessment in mathematics, which consisted of 40 items. Their estimated mean is 24.1, and the median class is in the 21 to 25 class range. So their estimated median is 23.72727272 or 23.73 if rounded off to 2 decimal places. The model class is 16 to 20 since it has the greatest number of frequencies. The standard deviation is approximately 7.82879,301 or 7.8288 if rounded off to 4 decimal places. Finally, based on the histogram, we may conclude that the distribution table is positively skewed because the curve is skewed in a positive direction.